Hey guys, let me show you how number 3 in section 310, the related rate section works. It should be a very straightforward problem. So notice here in the problem it says that we're supposed to assume that the radius r of a sphere is expanding at a rate of 80 centimeters per minute. Instantly you'll see I went ahead down here in my work and I said, okay, that's a given. That's the change in radius with respect to time. The radius is expanding at a rate of 80 centimeters per minute. So the change in radius over the change in time. One of the key components in these related rates problems is understanding the rates that you're given. That first sentence gives me dr dt. Now, it's telling me what the volume of a sphere is, 4/3 pi r cubed, and that the surface area of the sphere is 4 pi r squared. Surface area of a sphere ends up being extra information you do not need in this problem. Now, I go on to the third sentence here, and it says, the goal of this problem is to determine the rate at which the volume is changing with respect to time. So you'll see down here in my work, I said the goal of the problem is to find dV dt. That's the change in volume with respect to time. Now, the specific point in time that we're wanting is when the radius is 15 centimeters. So I came back up here to the given part and put r is 15 centimeters for given. Now, since I'm trying to find the change in volume, that surface area formula is completely irrelevant. You'll see I came down here, chose the volume formula, 4/3 pi r cubed. Take the derivative of that with respect to t. Well, the derivative of v with respect to t is precisely that, dv dt. On the right-hand side, you're supposed to be thinking of that the only differentiable function with respect to time is the radius, but you know that that radius is a group raised to the third power. So what happened in this next step is the 3 came down in front of that group, got rid of that 3 in the denominator, and I had 4 pi r to the second. And then you had to say times the derivative of what was inside of that group. Well, the derivative of the inside is the dr dt. Now, once I get my derivative taken, I can plug in any values that I know. So I had the 4 pi. I know r is 15 centimeters, so that's 15 centimeters squared there. I know that the change in the radius with respect to time is 80 centimeters per minute, so I put that in. So then when I went to the calculator and did the 4 times 80 times 15 squared, I got the 72,000. I would rather just keep it exact, so I kept it in terms of pi there, 72,000 pi, and we know that this is going to be centimeters squared times centimeters per minute, so we do get our cubic centimeters per minute. We should be able to go right back into our problem and enter that 72,000 pi. I'll try that here, 72,000 pi, and we'll check that answer, and you'll see that it is correct, and it will allow you to keep on moving on to the next question. Hopefully that helped you out with this question. Please let me know if you have any other questions. I'll be glad to help.